Hello, everybody, and thanks for joining our webinar on Beyond Monitoring. We're going to talk about how to use advanced analytics to produce actionable outcomes. So we're excited to dive into this, Johnny Dobbins and myself. Johnny, do you want to go ahead and introduce yourself?
Yeah, thanks, Alec. My name is Johnny Dobbins, and I'm the VP of Engineering at NarrativeWave. My teams lead the data engineering and product development, and I've been working in this space for about 15 years, mostly with Python.
Great, thanks, Johnny. Johnny loves to talk about Python. So
yeah.
So I'm Alec Miller. I'm the VP of Product here at NarrativeWave, and I lead the product as well as a lot of the renewable engagements. And my experience is about 15 years experience in the energy sector, as well as the last several years with NarrativeWave. So John and I are excited to talk to you about this and to walk you through our presentation here. Just a bit about NarrativeWave to get started. We work across several different renewable energy sectors, including wind and solar and geothermal and water. And this gives us a really good view of how people are managing assets and lots of ideas about best practices. And so we're excited to really share a lot of these learnings and approaches with you today. So let's talk a little bit about standard monitoring and a lot of ways that people have been doing monitoring in the past, and then we'll focus on how you can go past that to beyond monitoring. So maybe Johnny, tell us a little bit about what does sort of the classic standard monitoring look like? What do we see people doing when they do this practice?
Sure. Well, the first thing is lots of alerts. It seems like every client that we engage with today are basically inundated with alerts coming from everywhere, right? We've seen clients using dashboards that are like heat maps with red. Every asset they have has something wrong with it, and they really don't know where to go from there. And we've even engaged with people that were doing human checking of performance curves across thousands of assets. You can imagine how inefficient those approaches are. So, Alec, what are some of the downsides to this?
Right. So, we're really putting a lot of emphasis on the engineer and asking them to, review things, assign priorities, figure out what they mean, figure out if they're true positives or false positives. And so we're putting a lot of emphasis on, manual ad hoc reviews, manual diagnostics, right? And so this is a reactive process sort of by definition, the way this is structured.
Yeah, and the engineers, to that point, the engineers aren't doing what's most important for them or for the organization. They aren't focusing on areas where they can create new value.
Right, exactly. So now when they try to create the value and maybe do, corrective actions, how does that come to play here doing this approach?
Yeah, well, now we've got manually decided and often inconsistent corrective actions.
Yeah, exactly. So you can see we're going from, we're using analytics, but we're triggering lots of things, making the engineer do a ton of work and then decide what to do about it. So it's a pretty hands-on process and pretty inefficient overall. Okay. Yeah. All right. So let's talk about, beyond monitoring, actionable outcomes.
Yeah, Alex, since you came up with that, why don't you explain it a little bit?
Sure. So first, what are actionable outcomes? Those are, tactical outcomes that by definition have meaning to the organization and, can be followed up on with, an automated approach. So don't require significantly more manual diagnostics. And so we call this approach, beyond monitoring. And the approach here is, as you can see, is to shift the focus from the engineer into an automation and analytics layer, right? And that has lots of benefits in doing this. Johnny, can you, talk us through some examples of this at a high level? What does that look like when we've shifted the focus from the engineer doing this, to an automation approach using analytics?
Yeah, you bet. So let's start with what an engineer might do in an example. Consider a failing or a failed fan in an inverter cabinet. When this is happening, the engineer is having to check the temperature of the cabinet over time, seeing it rise, right? Manually looking at the data potentially or dealing with an alert. Then they're going to be looking to correlate that rise in temperature to a decrease in performance, eventually getting to availability issues on that individual asset, right? So you're spending all of this time diagnosing each of those things, correlating them together. And we think that a good practice for this is automating that process into a multi-step diagnostic, saving the engineer valuable time.
Mm-hmm. Yeah, another benefit of doing that right as you put this in place is that you get higher adoption because you're, focusing on the things that matter. So it's not just an alert, as you said, Johnny. It's a multi-step diagnostic, identifying the things that matter, right? And that helps the adoption piece. What else can you do once you have those pieces in place there?
Yeah, I mean, once you have that logic in place, the next obvious step is a corrective action, right? We can create automated corrective actions because we're going from what does this mean to be a curated finding of an analytic, and now the solution can auto-suggest a corrective action. Again, here the key is using the engineer's knowledge. That's the most important thing. You don't want to outsource that to some third party.
That's right. That's a key part of it, is that using the organization's specific knowledge, because then you're automating and detecting things that matter, right, to the organization, including specific corrective actions, right?
Right. And we recently done a case study with one of our clients on this. Why don't you talk about that?
Yeah, that's right. We published a case study with RWE, who's a very large global renewable operator based out of Europe, and they're going all the way in their case from faults coming in to automated corrective actions. And so in their case, they're using that automation stack to say, if we see a certain fault code, let's do some logic on it and some analytics to analyze it. And then let's go all the way to what is the recommended corrective action. You'll see that case study on our website as well. So just an example of an end-to-end automation application of this type of approach that you can do. Okay. So let's take a look at some of this in action, right? Let's take a look at the product. We're excited to show you some specific examples of this, and we'll talk you through those. All right, let's switch over here. Okay. So we're here inside the NarrativeWave solution, and we want to show you an example of what does an actionable outcome look like when you've created it, and what are the different components of it. Okay. And so the first thing that you can see here is this is the result of an analytic here. This happens to be an analytic about solar. And you can see it's not saying something simple, as Johnny mentioned, like a temperature threshold was crossed. It's saying something very valuable, that it sees heat-based clipping and a cooling fan or a filter failure. So it's doing a diagnostic here and coming to a specific conclusion that can actually include specific recommended actions. Okay, so first let's take a look at what are these steps that you might want to put together as a best practice to do this yourself. Okay, so let's show and take a look at what this analytic looks like, and I'll back out a bit, and you can see here that we've displayed this analytic visually. Okay, and the point here is that you can see that there's different flows that can happen through these different boxes, and each box is an equation or an analytic or a test of some type. Okay, in this case, we're checking a few different things here. We're looking for power anomalies in this box. We're looking to see temperature overheating in this box. We're looking for cabinet temperatures here. Checking for a pattern that recognizes inverter clipping, and coming to a box that's called heat-based clipping cooling fan failure. Okay, and so you can see here we're combining two important things, which is we're using analytics, but we're also using an engineer or an asset manager's knowledge of what do these mean. What does it mean if I see this type of clipping at the same time we have a power loss and a temperature signal? And here it probably means that we have heat-based clipping and possibly a cooling fan failure. Okay, and so this is one way to put together as a best practice the logic steps, combine engineering knowledge with analytics, put those together, and then this runs automatically and comes to a very interesting insight, right, which is going far beyond a simple alert. Okay. All right, so let's take a look a little bit about what's happening inside these analytics. What's going on under the covers here? How do you make this happen? What are the best practices?
Yeah, so let's talk about the best practices. Let's jump into our analysis folder, and we're going to be looking at a configurable building block or a Python template and talk about some of the best practices we use in order to put this into place.
Okay, great.
So number one in this is make it easy to change and make it flexible where it can be applied across many things. And when I say it, I mean the underlying analytic that you're doing, right? No one wants to work with hard-coded analytics that are not flexible or that are difficult to change, right? So that's number one. That's the top best practice we think you should be adopting. Number two, augment your knowledge with machine learning. We're not saying machine learning should be everything for you, but typically when you're doing an analysis, you will want to take the approach that you use internally today, perhaps augment it with the machine learning approach, and then use a community or a standards-based approach to have three different variations of the same analytic, right? And we're looking at three here for loss production, right? We're doing a standards-based flipping approach. We're looking at power versus irradiance with the regressor. And finally, this power anomaly, we're using a multivariate regressor of this, right? So let's look into that a little closer. You can see with the equation template that's there, that's this building block. And it's important to build trust around your analytics if you want them to be adopted. And we feel very strongly about this, that you should be able to trace the results of your analysis back to the actual Python if you want to be able to do that. That transparency builds confidence in the results. And we think that confidence level is one of the biggest drivers of adoption. How did you get to that result? Some other best practices, as we mentioned, are using multiple approaches to look at the same thing. Again, building that confidence level up.
Mm-hmm. That's great, right? So we see the examples here, right? As you said, we've got different approaches to looking at production losses, and we're using both statistical and more advanced machine learning approaches, and these all sit on that tree that we showed. So you get this very rich look at what's happening on your assets, combining it with human knowledge to say, what does it mean? And we're going to do a subsequent webinar, right, Johnny, on machine learning and show you a bit of how would you do this yourself, right?
Yeah, it's going to be exciting.
Yep. Okay, so this is a bit inside and some best practices about how you would do this. How do you put these together? Okay, and once you have those components working and assembling, Johnny mentioned making it easy to use and consume. And so one of the other techniques that the best practice we recommend is use visualization techniques to visualize the results of analytics. So again, this is not just visualizing alerts and creating heat maps of things that someone has to sort through. So for example, this chart here is showing the results of loss production. So this is irradiance versus power. And here you can see we have some of these dots in red. And so we're automatically classifying those as loss production. And this is a technique some of you might very well be doing today. And again, this is a great technique. Visualize the results of analytics, not just the inputs to them, right? And you can see here, this is a visual representation. And then in some of the machine learning techniques, we also use text-based summaries. And so this is one of my favorite techniques, as Johnny knows. I love to talk about this one because this is a multivariate regression technique where you could give it a few different data tags, and you can ask the analytic which of these data tags seems to correlate closest to the power output. And in this case, it's saying, hey, your heat sinks are most closely correlated, and it's supposed to be irradiance because this is a solar plant, right? And this is right. So this is an example of it finding something that a human engineer might not find, or particularly won't find at scale. And so, the best practice here is, help to summarize the information coming out of the analytic in an easy to consume way. All right. And, you could do this too. This is tying this all together. So one more thing to think about is once you have these pieces in place, you can also start to do the last piece, which we showed on the previous slides, which is corrective actions. And so indeed here we have two suggested corrective actions for this finding, right? So here's the first corrective action, which is replace the filter along with some checks to do. And here's the second corrective action, replace the fan along with some checks to do, right? And so this is an integrated view of this, and a lot of companies have, CMS systems or maintenance systems. A lot of them are not tied into the analytics stack. If you can get those two talking together, you can do really interesting things like this, which is auto-suggesting the corrective actions. And you can also do very fun things like getting feedback on these corrective actions. For example, does this corrective action tend to work? And you can see we're scoring it here. And again, lots of people have these systems.
Just real quick, Alex, sorry. One of the exciting things about this, and it's coming from my Python background, is we can take this this human response and then feed that back into the analysis even and improve the underlying analysis and the ML components. Again, bringing in your engineering knowledge into the analysis process.
Yeah, that's right. And that's one of the things we're working on enabling further in the future. You can look at these events, you can see how often do they happen, when do they happen, how did we fix it, all kinds of exciting things in the analytical area.
Yeah.
Okay, so I want to show you a bit of our solution here. Now let's flip back and maybe a few best practices on, how would you enable this? What are the ways to get there yourselves? And so, these are the 3 best practices here, really how to think about doing this. And the first one is one of our favorite techniques, which is simply working backwards from what matters. And when we say what matters, we really mean what would your organization want to take action on if they saw it occurring. And so a temperature threshold is not always the answer. That's a part of the step along the way. But what really matters is, are we seeing the precursor of a component failure? Or are we seeing temperature rise that's causing the lost energy output, for example? And so, as Johnny mentioned, tying in those multiple views of lost output to the trigger of what's happening, right, might be a richer starting point. And then, of course, you can figure out what do I need in the analytic or the automation layer or the KPI, to get there. So that's sort of the first approach. The second approach is, use human context, right? If you ask your asset managers and your engineers, what do you do when you see this type of thing happening? They'll tell you, we check this and this and this. We check the neighboring, solar inverters or the neighboring wind turbines. Oh, so put that back into the analytic and help them do that part of it. So that human context is very valuable, right? And the last piece, John, you want to talk a bit about sort of corrective actions? How do you enable that in this stack here?
Yeah, so that's the last key piece of this, right? Once we have our tree in place and we're doing these multiple checks in an automated way, we want to get to that automated corrective actions piece, right? This is where when data is presented from your analysis, you quickly get back those recommended next steps, and bringing in that human context to this again is really key. How do you do it manually today and then implement that into this advanced analysis? And the goal always is getting you to those corrective actions quickly so you can resolve the issue and then stop losing your revenue related with the loss there.
That's right, exactly. Okay, so these are the 3 ways to sort of think about it. And we found these very valuable. Just take this approach, you get some really interesting outcomes from it. So, what are some of the benefits? So the first one is it improves engineering productivity, right? And you also get to work on more fun things because you're automating a lot of the initial views, right? And so you can focus on where the value is. The second one is, people will tend to use the analytics more. And we've seen that, when a predictive analytic triggers that people have helped create and they know what it means, they're going to look at it very quickly, right? Because they know that it's important and they know to follow up on it. So it increases adoption of analytics far beyond sort of simple alerts. The result of all that, of course, is that, your time is freed up to focus on, improving the assets, finding the smaller problems that you can improve. So those are really the first 3. And then, going forward and a bit longer term, you can also think about this as transforming the way the organization thinks and works. So instead of reacting to things and following up on alerts, you're now sitting and improving the analytics, right? Because every time they trigger, the more you can improve them, the better the cycle gets. And so people's attention is now focused on this transformation, using these things to drive automation, to drive valuable insights and actions. So these are some of the benefits we see both for the engineers as well as across the organization. So thanks everybody for joining us today. We appreciate your time. Just so you know, there'll be a more in-depth article available both on our website here, and we'll also send the link to this in an email so you don't have to write this down. But thanks everybody for your time, and we'll jump over now to a Q&A session. We're excited to have a discussion with everybody.
Thank you.
Okay, great. If you're not familiar with GoToMeeting, there's a section here where you can put questions in. We see a few in there already, so we'll take those sort of one by one. But thanks everybody for listening. And now we'd love to chat and answer some questions. So the first one that's coming here, Johnny, is if a recommended action is taken, but the problem was not resolved, would that impact the future recommendations? How does that piece of it work inside there? Do you want to take that one?
Yeah, sure. I'll take that. So just in terms of speaking about best practices, of course, if you're taking an action and it doesn't resolve the issue, then in our system today, it actually scores that recommendation lower, right? But just in terms of implementing this outside of any particular system, best practice would be if it doesn't solve the problem, then not only take it out of the scoring, but also maybe underweight it a little bit. So yeah, thanks for the question.
Mm-hmm. That's right, and once you start there, as Johnny said before, once you get that loop going, you can add in lots more context and details. Like how long, how often does this corrective action get used? How long does it take to solve the problem? All kinds of richer things you can add into that piece of it. So, but the key piece is linking the feedback right to the analytics. So, okay.
Right.
Another question coming in here, Johnny, for you, I think. So, how do you select which machine learning approach to use? So maybe talk about some of the different approaches and how you sort of think through those.
Yeah. So we use two pretty predominantly here, just in terms of expected output or expected power. That's one that we use a lot across multiple verticals between solar and wind and geothermal, right? In this expected output ML equation that we have put together, we're using a decision tree regressor, right? And we found that that works best across multiple different asset types. Another that we like to use is an LSTM, which is really great for building patterns, pattern detection in the data. So if you have a little bit of data depth, you can put this together and use it to identify anomalies in the data, right? Those are our two go-tos, and there's really simple ways to implement those in our system.
Yeah, and an LSTM is a type of recurrent neural network, and like everybody, we were always curious, where are these things work very well, and so we've had a chance to apply that first in the water sector, and then we applied it to wind and solar. So there's some great ways, as Johnny said, where they can solve real problems. You can give it a signal and say, hey, this is normal. Tell me when you see abnormal. So it's a really useful approach, right? That we really like.
Yeah. So Alec, the next question coming up is how does the system address data quality issues? Yeah, so NarrativeWave, and just speaking generally in terms of best practices around analytics, we've implemented these best practices. We have a preset number of data quality checks, both on data ingestion, where you can do cleanup of the data, looking at things like missing data, flatline data, interpolated data, et cetera. So in data ingestion, we're performing these checks and then identifying which data points have these problems. And then on the other side of that, during the analysis itself, when you're performing this performance analysis, you can also have outcomes that say your equipment was underperforming, but the data was unreliable because of X, Y, and Z.
Right, exactly. So lots of different practices, and one of my favorite that uses sort of human knowledge is just take an approach of, is this sensor too high to be believable? So you could think of it as data quality checks, as well as how would an engineer look at it and say, well, that doesn't make any sense, right? So you can do things like that too, just to make it really easy to use and understand. Okay, next one up, Johnny, is what data are you using to make these recommendations? SCADA, CMMS, condition monitoring, and are you able to use weather data as well to help optimize the corrective actions? Do you want to take that one?
Yeah, you bet. So all of those actually. The SCADA data is important for identifying the issues. You know, we saw that decision tree before. Those are basically just a collection of equations that operate on the SCADA data. Adding to that, you can bring in, of course, weather data. If you have a Met tower on your site, of course, that's great. Or you can bring in a commercial source, irradiance data, for example. We also integrate very well with, and you should integrate very well with CMMS systems or external work order systems. Participate in that ecosystem instead of trying to get all.
Right, and another example for weather is you could take, create an expected power output that uses wind speed, for example, and then take the weather forecast, and so you can say, well, A, what's my expected power, tomorrow, for example, or the next day, and then B, is that a good time to take the corrective action? And you can put those into those multi-step type processes and use it to optimize your, when should you take that corrective action, right? Is a great use of it. Okay.
So the next question up, if you don't mind, did you automate any vibration spectral analysis? So I missed one of the data types, right? So talking about frequency domain data, of course, being able to ingest and consume that, and then do any types of transforms that you would want to be able to do on it. We have some of these building blocks in place, and we've used them in a couple of different verticals, and it's based mostly around different fault modes on bearings. Yeah.
Okay, great. So the next question is, does the algorithm analyze real-time data? Maybe let's take that as terms of a best practice question. So yes, these analytics can use data as often as you're collecting it. So if you're doing 5-minute data on solar, 15-minute data on wind, for example, our best practice is only run the analytic as often as useful to save your server capacity and time, right? We've had some that are very valuable analytics that run once a week, just because they were looking 60 days ahead of time in the future, so you don't need to sit there and run it. Maybe you're doing something much more real time, like vibration, and in that case, one of the best practices is to micro batch that data, pull in a lot of it because you're doing millisecond level data, right? And so you have to be tuning the data ingestion to how the needs of the analytic. But the answer is yes. If you need to do it closer to real time, then that's how you run them. If you can slow it down, then save your server capacity, then that's sort of how you want to look at doing it, right?
Yeah, and one of the best practices we've seen around that is seeing if I can run this real time, can I respond to that in real time? And often people come to us and they have the data streams and they're ready to do it, but once we talk about how actionable those outcomes are and what you would do with it, they suddenly realize that, well, yeah, I mean, it's nice to think about it, but we can't, with our current infrastructure support or with our current support teams, support dealing with real-time responses like that. And we see people doing macro batches in a minute, 5 minutes, even an hour. So think about that whenever you're considering real-time analyses. Alec, we have a question here. Someone's asking about our website, talking about self-service and what does that mean. Do you mind taking that one?
Sure. So our approach to self-service is that asset managers and performance engineers, people who know the assets the best, should have their hands into the solution, being able to do things like create KPIs, adjust persistence, change thresholds, without needing to use the Python layer or be a data scientist. However, part of that approach is saying, hey, if you want to use that layer, you should be able to. And so for us, we look at that and say, what does self-service mean? It means transparency and access, right? And you can even take that further and say, hey, maybe someone who's operating a certain site, for example, should be able to do it themselves because they want to define their own KPIs and their own view of their assets. So for us, that's really important, and that's how you get the knowledge in there. The specific knowledge you need is be able to do it yourself. Don't port it off to a third-party solution where you don't have control and access, right? So that's kind of our flavor of it. Yeah. Okay, Johnny, one for you here. So how do you tackle inconsistencies observed in expected energy models? Any idea on using machine learning approaches, using historical data?
Sure. So depending on which vertical you're working in, it may vary a little. But we've found that when trying to look at expected energy issues, it's best to take multiple approaches. Most people that we've worked with have their own approach. It may be a little variation of something that the community has accepted or that is standard based. We also have our own building block that's a stats-based approach, and as well as an ML approach, based largely on two things: nameplate expected output from the assets, and also the historical observations of those assets. That gives you kind of 6 different perspectives around what that expected power should be, and then you can build a higher level of confidence around what the analytics are telling you because you're having these different checks happening.
Okay, great. Another one here around predictive analytics. I've heard, it says, I heard you need lots of data and failures, I guess failure-related data. What's an example, or how do you tackle those? How do you create, predictive analytics? Is the question here. Yeah,
sure. So I think it's just a common ML approach to have historical data that has been labeled. Can be labeled by a human, or you can build an equation that will identify that particular data signature and label that data for you. And then basically just train your model on that labeled historical data, and then feed your real-time or your near real-time data into that, looking for deviations from the expected. This gets you to anomaly identification and even predictive future-based anomaly identification.
That's right. And one of the other ways we think about it is, you need a lot of data if you really want to do a prediction of when something's going to occur with high specificity. But again, part of our approach that we like is work backwards from what matters. So do you really need to know when it's going to occur? Or if it's okay to know this is a high probability of failure, what is your organization going to do? They're probably going to inspect it and go take a look, right? And so for us, you can also get to predictions if you define a prediction as, hey, tell me if it's got a high probability of failure, then the organization can very well take it from there and go investigate it, right? And so that helps.
These questions are all great. These questions are all great. We kind of set up in our discussion earlier that our next webinar is going to be around using ML and AI in analytics. So we're going to take some of these questions that you guys are asking and answer them in more detail in that next webinar that we're going to put together. Thank you for these questions.
That's right. So we want to show people how do you do this in Python, and we'll show some of these examples, right, and put them up there, because we're all about transparency and showing you how to do it, right? So yeah, we're excited for that one. Okay, any other questions you see there, Johnny? Let me just check. Okay,
we've gone through the list.
I think we've got through the list there. So unless anybody has a last minute question there, we're, thanks everybody for joining us. And, Johnny and I love to talk about analytics and data and machine learning and energy. So, please, of course, feel free to reach out, and, we're happy to chat further and dive in more technically if you'd like. So, but thanks everybody, really enjoyed the time. Thanks for joining us, and look forward to talking again soon.
Awesome. Thank you, Alan.
Thanks everybody.